So, good people, I'm going to demonstrate how to deal with a two-step problem that involves molar calculations. Capsaicin is one of the active components responsible for the hot taste of chili peppers. How many molecules of capsaicin are present in 1.35 grams of the compound? Note that the question is asking for number of molecules, not number of moles. And so, capital N is the unknown. According to the triangles in the bottom right, number of particles, in this case molecules of capsaicin, is equal to number of moles multiplied by Avogadro's number. Unfortunately, we have not been given the number of moles. Instead, we have been given the mass of the compound. How do I go from mass of the compound to number of particles of the compound? The formula for number of particles, in this case molecules, requires number of moles, lowercase n. And if I look at my triangles, I can see that number of particles and mass are connected via number of moles. So, I need to make a bit of a detour. I need to calculate the number of moles first. And the formula for number of moles is N equals mass over molar mass. The molar mass of our compound can be obtained from the periodic table and the molecular formula. In this case, the molar mass would equal to 18 molar masses of carbon plus 27 molar masses of hydrogen plus 1 molar mass of nitrogen plus 3 molar masses of oxygen. And all of that comes together to 305.418 grams per mole. Now I have everything to calculate the number of moles, and it will be 1.35 grams over 305.418 grams per mole. According to my calculator, that is 0.00442 moles when rounded to three significant figures. Now that I have the number of moles, I can calculate the number of particles. I'm going to copy the formula for the number of particles. And now I'm going to substitute. And that will give me 2.66 times 10 to the 21st molecules of capsaicin. Note that this was a two-step problem. We needed to calculate the number of moles before we can calculate the number of particles. Now, for those of you who like to play with mathematical formulas, this formula at the top that we used for the number of particles and the formula for the number of moles can be combined. N, the number of particles, equals the number of moles. But the number of moles is same as mass over molar mass. And all of this needs to be multiplied by Avogadro's number. By manipulating mathematical formulas, we can solve this in a single step. That being said, my strong recommendation is to treat it as a two-step problem. Calculate the number of moles first, and then use that to calculate the number of particles. Let's try one more. Fructose is a simple sugar found in fruits, and when combined or bound to glucose, it forms the disaccharide known as sucrose. And sucrose is the scientific name for the sugar that we use every day. The question here is, what is the mass of 2.36 times 10 to the 22nd molecules of fructose? In this case, we are after the mass. If I look at my triangles, I can see that I can calculate the mass by multiplying the number of moles by molar mass. I do not have the number of moles, but I can calculate the molar mass. According to the triangles, the mass of a compound is equal to the number of moles multiplied by the molar mass. We have the molar mass, but we still do not have the number of moles. Luckily, the question has also given us the number of particles, or in this case, the number of molecules of fructose. How does that help me? Well, according to the triangles, yet again, the number of moles is equal to the number of particles divided by Avogadro's number. And so I'm going to say that lowercase n equals capital N over Na. I can substitute, and according to my trusty calculator, that will give me 0.0392 moles of fructose when rounded to three significant figures. Now that I have the number of moles, I can use my formula for mass. Let me copy it. And as before, I'm going to substitute. And unless I have entered the numbers incorrectly, that gives me 7.06 grams. As before, this two-step process of finding the number of moles first and then calculating the mass can be combined mathematically into a single step. The mass equals number of moles, but number of moles is the same as number of particles over Avogadro's number, and that would have to be multiplied by the molar mass. If you wish, you can try to solve it in a single step using this formula. However, as I have stated before, I strongly encourage you to approach these as a two-step problem. Determine the number of moles first, and then use the number of moles to calculate the mass. That is all for now, and I will see you on the flip side.